All right, welcome back, wonderful people. Let's see what we got today. So by the end of this lesson, you should be able to solve absolute value inequalities and graph solutions and write them in interval notation. So pretty much what we've been working on for the past couple of lessons, actually, we have covered absolute values. So like absolute value equations. And remember, those are the ones where there's two solutions. And we've also been graphing inequalities in general, really. So graph inequalities and then write them in interval notation. So those are some of the things. So we're just bringing two of our previous lessons together. So what you need to know. So an absolute value inequality. So what are they? So like, let's say I want to graph numbers. I want to graph numbers that have a higher absolute value than 7. So what numbers have greater absolute values than 7? Well, we could try picking some things and seeing if they make sense. So like in this case here, if I pick 2, all right, so if I pick 2, is that going to work? Because if I put 2 in here, the absolute value of 2 would be 2, and that's greater than 7, and that would be false. 2 is not greater than 7. All right, and if I said greater than 7, you might be thinking, well, 8. 8 works out. 8 is a number that's greater than 7. So if I take the absolute value of 8 and plug it in here, absolute value of 8 is positive 8, and that's going to be 8 is greater than 7, and this is true. So this is actually one of the solutions. But what else would there be? Well, let's see. Another possibility. Well, what if we were to pick negative 8? So if I pick negative 8, that would make this, the absolute value would turn that into a positive. So I'd get positive 8 is greater than 7. So actually, negative 8 would also be a solution. So again, don't forget the absolute value sign. Well, literally it means a number's distance from 0. But actually in this case here, it would actually also be the one where I said everything you put in there becomes positive, which is true. Everything does become positive that you put in there. So how we would mark these, well, you start with the number you have. In this case would be 7. So I'm going to mark 7 with a closed circle because we are using the same rules that we had before. And we know that it includes 8 and negative 8. So it goes this way and that way. And if I pick a number like negative 4, if I plug in negative 4 for x, just to check it, make sure that these arrows are pointing in the right direction, negative 4 will become positive 4, and I get 4 is greater than 7, which is false. So nothing in here should be a solution. And that's how you would graph this one here. So again, compound inequality means that there's two things graphed on the same number line. And then interval notation is also going to be the same. So once you have it graphed, interval notation should be not too bad. Start with your lowest number, which in this case, the lowest possible value would be negative infinity. And we go up to 7, including 7. And don't forget, when you include a number, you have to put it in a bracket. So the bracket's on the 7 side because the 7 is included. And then it goes, oh, sorry, negative 7, because we're going from the left to the right, and that'd be negative 7. And then up to 7, which kind of was confusing because this is also included, positive 7 to infinity. And there you go. So that is the interval notation that goes there. Now, this second case looks very similar to the first case, but there is one small difference, and that is the opening direction of the mouth is open towards, well, in the top one, it's open towards the X. Over here, it's open towards the number, away from the X. So how is this going to look different? Well, let's try some numbers again. Now, if I pick 2 2 is less than 4, that's true. If I pick negative 2, that's going to make, this thing's going to make it into a positive 2, so 2 is less than 4, which is also true. So I know that 2 and negative 2 are solutions. But again, once it's solved, we should be able to get those numbers. So we have 4 actually. And in this case, we'll need a closed circle, but it would also have negative 4. So anytime you have an absolute value, you have to consider 2 possibilities, that it's going to be a negative and a positive case. So there are going to be 2 cases possible. And we want numbers, and remember how we said that negative 2 and 2 are both solutions. So therefore, we already kind of checked it so that we know the solution is going to be between negative 4 and 4. And again, if I pick negative 4, put negative 4 where x used to be, that's going to cause it to become positive 4. And positive 4 is less than or equal to 4, so that's true. If I pick negative 6, put a negative into the absolute value, you get 6 is less than 4, and this is not true, that's false. In that case, the mouth would not be open towards the bigger number, which would be 6. Anyway, let's go ahead and do interval notation for this one here. So starting with our lowest number is 4, and greatest number is positive 4. So there we go. Interval notation is done. Now again, these are 2 cases. If you remember, there's 2 possible ways that we would say this, and the first one would be or. So think about driving down a road. Okay, if you're going down a road and you see 2 paths, 2 roads, is it possible to go down both directions at once? No, right? I mean, unless it's a cartoon, you can't go both directions. And if it's and, then it has to include both of those. So this would be an and statement. So again, we're still bringing in the same thing where we have an and or statements. All right, let's go ahead and get on with some of the exercises that we're going to be going through. As always, hopefully these make a little bit more sense once we actually start to cover some of these in examples. All right. So an absolute value inequality is also a compound inequality. All right. So again, compound inequality means that it's 2 graphs, two things graphed on the same number line. So these are going to be compound inequalities. So the steps to solve, and again, some of these are going to be the same. So we did work with, we have worked with absolute value equations before, and the rule is the same. The first step you would do is isolate the absolute value expression. So the thing that has the 2 bars on it, we got to solve that first, okay? Got to solve that thing first. Now, once your absolute value expression, the little bar things, once those are on the same side by themselves, you would create 2 cases. So there's 2 cases because, well, there's a positive case and a negative case, just like we saw in the last example where we had the 4 and the 7, right? You can pick the negative one as well. So we use this, what we call KISS, which stands for keep it and switch for those 2 cases. Then we would solve both sides, both inequalities, and then graph it and put the answer in interval notation. So those are the steps that we would have. And again, these steps are not way different than anything we've done before. In fact, it's kind of the same. So let's, like I said, let's get into some of these examples. It'll probably make a lot more sense once we get into it. So let's start off with well, this one. This one's kind of an easy one. So starting off with the first step, we got this thing by itself already. The absolute value is already isolated, right? I don't have any numbers on the outside on the same side. So it's going to just be breaking it into two cases from here. So we go straight to step number 2. So remember the keep it. So the first case stays the same. We don't change anything about it. Everything looks pretty much the same, except we don't have the absolute value things anymore. So the absolute value, gone. But the second case, and we need both cases in order to get the right answer, everything on the inside stays the same, but everything on the outside switches. So when it says switch, switch, you're switching two things. You're switching the direction of the mouth, and you are also switching the sign of the outside numbers. If there's more than one number, you're gonna have to switch everything. But in this case, we only have one number, and that's 7. So we have to switch that to a -7. And there we go. So that was the second step. Then the third step was to solve both inequalities. So I got 2 inequalities here. And since they're pretty much the exact same inequality, I can pretty much just do the same thing to both sides. So in this case, I'm gonna have to -6 from both sides on both inequalities. So x is greater than -1 and x is less than -13. So negative and negative will combine to make a bigger negative. So now I think we're ready to graph these. So let's see, x is less than 13. So if I want an x value that will work, I'm gonna have to pick something less than 13, which means I'm gonna have to go this way, which, yeah. And you can always check it too. Check it by plugging it in. Plug in something that you know is less than -13. Like if I pick -14, put -14 in here, -14 is less than -13. That's true because if you have if you have two negatives, you want the one that has the lower value, the lower absolute value. In other words, the one that's closer to 0. All right, now let's go ahead and do this one. So x is greater than -1. So I'm gonna mark out -1. Don't forget to use the right kind of circle. Remember, we have a open circle, which is used for numbers that are not included. And I need numbers greater than -1, which means that I'm gonna have to go to the right. Or again, you can plug it in. Like if I pick 2, right? 2 is greater than -1, that is true. So that means that this is pointing in the right direction. Now we have to identify what kind of compound inequality this is. So this is an OR statement. Again, ORs will face away from each other because it's like a road. You cannot pick a road. You cannot pick more than one road. You know, if you have a road, you have to go left or right or whichever directions they're going. You cannot possibly pick both roads. So again, this is like a left turn or a right turn. You cannot pick both of them. Okay, so interval notation. So starting from the lowest possible number, we have -8, and that goes to, let's see, -13, and it's not included, so we're going to use rounded parentheses to show that neither of these are included. Union, so we have a second one, so that means this solution set is also going to be included, and that one goes from -1 to +infinity. Okay, so from -1 to +infinity, and that is the second area that we have solutions in. Okay. All right, time for the next one. Okay, so same thing, isolate the absolute value expression. So here, my absolute value expression is 2v minus 3, and it's already by itself. It's already by itself, so I don't really need to do anything. So let's go ahead and go right to step number 2, and that is to split it into two cases. So splitting it into two cases, we have the positive case, which means nothing changes, so keep it, right? So keep it. And then we have the other case where it would be the negative case. What if the number we plug in was a negative? And that would mean switch, switch. So switch this sign and switch the sign on anything on the outside, which in this case, I only have one number on the outside, which is 19. So it becomes negative 19. So again, keep it. So keep it. That's what KI stands for. Switch, switch. So switch these two things. All right, now that I have my two inequalities, I'm going to go ahead and solve each of these. So +3 here and +3 here on both sides. And again, these are both pretty much the same thing, so I can pretty much do the same steps on both of them, and it should still be true. All right, so 3 is gone, and now we have 22 here. 2v greater than, let's see, what would this one be? That, I think that'd be 16, well, negative 16. All right, so far so good, nothing really all that confusing. Now let's see, I'm gonna have to divide both sides by 2 because I want that v all the way by itself. So put that v by itself. And since they both have 2v, go ahead and just divide everything by 2. And that's the great thing about these, sort of like with the other ones. You can kind of just do the same thing on both sides and shouldn't really be all that different. So let's see, v is less than 11. And for this side, we have v is greater than -8. So those are the two possible solution areas that we have. So in this case, v would have to be less than 11. So I'm going to go ahead and mark out 11. So v11, so that would be right there. And over here we have v values greater than -8. So greater than -8. So open circle. And if I want numbers greater than -8, I'd have to go this way to the right. And over here, I'd have to go this way. So v values less than 11. So there we go. Now I can see just a little tiny pointer in both directions because there's a chance, you know, they might face away from each other. But one thing is, again, they will probably never face the same direction, okay? They will never face the same direction. So that means that they're going to have everything in between there is a solution. So all v values greater than -8, but less than 11. So that's going to be an AND statement. So I'm going to put a little AND symbol there. You can spell out the AND as well. And you can put it into condensed form as well, but you don't really need to. It's not really, you know, super important. So I guess we only have one thing to do left, and that is to put it in interval notation. So least from lowest, we got -8, and that goes to 11. And neither of them are included, so we're going to use the round parentheses to show that neither of them are included in this interval. All right. And that's it for that one. So far, nothing really that tricky. Just keeping it basic. All right, let's move on to the next one. Keep things moving along. All right, this one has a fraction in it. And again, don't be scared of fractions. Just remember, fractions are more scared of you than you are of them. This one is already by itself. Everything inside the absolute value is already by itself, so we don't need to worry about anything. So let's just go straight to putting it into two cases. So everything on the inside stays the same, but on the outside we switch the direction of the mouth, and then we also switch the sign of any outside numbers. So there we go. We have our two cases. Let's go ahead and solve both cases. Now, I want to get rid of this fraction. You can work with fractions, but I like that trick that we can just get rid of our fractions, right? That's a pretty good trick. And that is to just multiply everything by a bottom number, or look at the bottom number and look at what you can use to cancel it out. So to cancel it out, we need a number that can be divided by the bottom numbers, which in this case, we only have one bottom number, and that's 3. So the smallest number that can be divided by 3 is 3. So I'm going to multiply everything by 3. All right, so make sure we triple everything. And here I have 3k over 3, which is basically 3 divided by 3, which is 1 times k. So that's just going to leave me with k. And no more fractions. See, that's why I like this trick. Just fractions are just gone. And that keeps us from having to work with fractions. And it's a good thing to learn how to add and subtract and multiply and divide fractions, but in this case, I just don't have a lot of time to cover all that stuff. Anyway, maybe I'll have an optional lesson one of these days about that. It's really worth going over it, but yeah, there's a reason why people don't like fractions. Anyway, let's see. Now the next thing I got to do is get rid of this 15. So I'm going to add 15 to both sides. And that will cancel the 15 here and there. So now I have k by itself. So k is greater than 18. And k, well, I don't know if it's an and or an or, but my other one is going to say k is less than, let's see, 15 minus 3 is 12. So there we go. Now we have our two inequalities. So let's go ahead and graph them. And right now, we don't know if this is going to be an and or an or statement. So let's see, k is greater than 18. So greater than 18 means that I'm going to have to go this way. And again, check it if you have to. Like 20, if I pick 20 greater than 18, that's true. The mouth is open towards the 20 and away from the 18. So it is, trying to eat the bigger number. So let's do this one now. K is less than 12. So mark out 12 with a closed circle because it is included. And we can pick a number like 6. 6 is less than 12, and the mouth is open towards the 12 and away from the 6. So we know that's the right direction. Now in this case here, we have an or statement because they're facing away from each other. And again, it's like, you can have a cake or you can eat it, but you cannot do both. Kind of like me, I have the Mulan Szechuan sauce, but I can either have it or I can eat it, but I cannot do both because if I eat it, then it's gone. But then I can have it and show it off to everybody, but then I won't get to eat it. So I have two choices there. Anyway, let's go ahead and put it into interval notation. So this one does include infinity. So starting with your lowest value from negative infinity, work your way to the right. And 12 is included, so I'm going to use a square bracket. Union, and that's going to mean that this part is also going to be included as well. And that's going to be from 18, including 18, so square bracket, on to positive infinity. And there we go. So that's it for this one here. Not too bad. Just don't worry about those fractions, okay? Fractions are not so bad once you get to know them. Anyway, let's go ahead and move on to number 4. So for number 4, check it, make sure that the absolute value part is, make sure the absolute value is included. I'm sorry, isolated, which it is, right? There's no other numbers on the outside of this, so that makes it kind of easy. So we can go right to step number 2 and break it into 2 cases. So first case stays the same, keep it. Second case, switch and switch. So switch and switch. Now we're ready to solve both of them. So we got to get this n by itself, which means we're going to have to minus 7 from both sides. And again, they're pretty much the same inequality, right? They both got the same things going on, so you should be able to do the same things on both sides. So negative 4n, 27 minus 7 would be 20. And here I got negative 4n. And they're both negative in this case, so I got a negative and another negative. So that's going to cause me to get a bigger negative. So in this case, 27 and 7 make 34, but they're both negative. So remember, when you have two negatives combining, they don't cancel each other out. They will join forces. Okay, just like comic book villains. If comic book villains meet each other, for some reason, you know, you would think two people that kind of like don't like society, don't like people, they meet up and they're like, oh, we should join forces. But I don't know, it's weird that it happens more often than not, that villains are like, nah, man, I'm doing my own thing. Well, I guess you have to have rising stakes for your hero, right? You want to make it more difficult for your hero to get done with what they need to get through the movie. And I wonder, yeah, I don't think, like, I don't know, if like real criminals, I think if real criminals met each other, I don't think they'd really want to help each other. In fact, more often than not, they would turn on each other. I don't know. Well, let's get to this. So here I'm dividing both sides because I got to get rid of the 4, but I also have to get rid of the negative 4. Wait a minute. All right. Hoping somebody would catch that, but that's okay though. Remember, there is one thing that we have to watch out for. This is the thing, okay, you got to be looking out for. You got to be vigilant because it's easy to miss it. And what's going on is that we divided by a negative. If you multiply or divide by a negative on both sides, or in this case by everything, you are going to have to flip the sign, the mouth. So the mouth was open here to the right. Now it's got to be open towards the left. So when you do this, when you multiply or divide everything by a negative, you're switching everything. So everything's got to switch, including the inequality. So this is what makes it different than solving an equation, because if you're solving an equation, usually you don't have to worry about the equal sign, right? The equal sign is the same on both sides, but here it's got to be flipped. And again, this is something that's really easy to miss. Anyway, let's get back to here. I have a negative divided by a negative, so this means that it's going to become a positive. But I am going to get a number here, so I could reduce this. I could reduce it to like 17 over 2 or something like that. But that doesn't make a whole lot of sense because, you know, we want to graph it. We want to know where this is. So I'm going to go ahead and divide this. So how many times does 4 go into 34? And we could let's see, go count by 4s. 4, 4, 8, 12, 16, 20, and then 24, 28, 32. So that's going to be 8. And 4 times 8 is 32. And subtract this and see what you got left over. So in this case, I have 2 left over. So that's going to become 2. My top number is 2. And my bottom number was 4. And it will stay 4. And again, I'm ignoring the negative because I already know this is going to be a positive number. Reduce this fraction. So 2 over 4. They're both even numbers. So I'm going to divide them both by 2. So I get 8.5. Now we can go ahead and graph it on our number line. So n is greater than -5. And I'm just going to put a little mark right there just to show which way it's going, because right now I don't know what this side's going to do. Well, you could probably tell, looking at it, if you could probably tell which way it's going to go and what's going to happen. But for most people, it'd probably be easier to just mark it like that. Anyway, n is going to be less than 8.5. Actually, that's not quite 8.5 yet, because I need to go a little bit past 8. So not exactly 8 and not exactly 9, but between those two. There we go. And n is less than that. So I need a value that's less than 8.5. So that means it would go this way. And I can check it again by putting a number in like 2. 2 is greater than -5, and 2 is less than 8.5. So that means that this is an AND statement. And I'm going to put an AND symbol in there. Or you can spell it out, but in this case, I think it'd be a close fit to have the word AND in there, just because of the way I wrote it. Anyway, so that tells us that our solution is going to be between -5 and 8.5, but we are also including them, so we're going to need brackets. So starting with your lowest number, which is -5, and then go to your highest number, which is 8.5. And there we go. So that's going to be it for that one. Not too bad. And let's get ready to go to the next one. What does this next problem hold for us? All right, here we go. Ooh, a division. Now, remember how when we were first starting, I was saying PEMDAS doesn't always work. I mean, it works most of the time. It's not completely useless, but there are also some things you got to remember. So in this case here, this is a group. Okay, both of them, the fraction and the absolute value, are both groups. That means that we're going to have to get rid of this 4 to isolate it. So I have something on the outside of the absolute value. So that means I'm going to have to, before I do anything, before we break it into 2 cases, we are going to have to get rid of this 4. To get rid of the 4, I'm going to have to multiply both sides by 4. And that's going to get rid of the fraction and hopefully isolate my absolute value expression. So in this case, my absolute value expression includes both q and -1. And any number times 4 and divided by 4 is just going to be that same number. At this point, I didn't do anything to get rid of my absolute value, so it's still going to be there. And this is going to be our new inequality. So from here, now we have it isolated. This absolute value thing is isolated, which means we can break it into 2 cases from here. And I'm going to write it over here. So q minus 1 greater than 8. So everything stays the same. Second case, switch and switch. So switch both of those things. Plus 1 to both sides, because I'm trying to get that q by itself. So that 1 has to go. Q greater than 9. And that's usually why I put a little tail on the q, so that way you can tell that it's q, because if I didn't, it would look pretty much the same. And let's see what we got here. So q less than -7. All right, looks good so far. Let's go ahead and graph it. So q is greater than or equal to 9. So we have the or equal to, so use a closed circle, like a closed door. We can pick it. We can land on the door. And q is also less than -7. So mark out -7 and less than. So q, if I'm looking for a q value that's going to work, I'm going to have to go this way. And again, plug something in if you're not sure. Don't use any shortcuts. All right, I'm just going to tell you, don't use any shortcuts. Just don't get in the habit of using them. I know some teachers teach them, but there is always the chance that the shortcut will not work. Oh, interval notation. Oh, okay. So looking at the lines on the graph, I can tell that these are two separate things. So that means this is going to be an or statement, right? Okay. I can either go left or I can go right. Actually, it'd be the other way around. But again, left, or right. I cannot go both directions. It's just not possible. I cannot go both directions. I'm gonna have to turn my car in one direction or the other. Again, cartoons might have the car split or something, but no. Anyway, let's go ahead and write it in interval notation. So starting from the lowest number, which is negative infinity, and it goes to -7, including -7. So we have the bracket, square bracket for this one too, because this is also going to be included. So starting from 9, we go to positive infinity, or just infinity. And that one is not included. We can't include infinity. So we're always going to use a parenthesis anytime we're working with that infinity. Whether it's positive or negative can't be included, because as soon as we find out what infinity is, we can just go one number past it, and now we have a new infinity. All right, and that's it for this one here. Looks like we're making pretty good time. So let's move on to the next one. This one is also not isolated. If I look at this, my absolute value expression, it's not isolated. It's got that 3 on the outside. So before I do anything else, we're gonna have to get rid of this 3. So to get rid of this 3, well, just do what you would normally do with an equation, right? So just get it away. Pretend, okay, this whole thing, just pretend this is all one equation. This is all just one variable. If this is all just a, like if I have a plus 3 is less than 25, all right, you would do the same thing. You would -3 from both sides. So I don't know if that helps. In fact, I can kind of see it maybe confusing some people even more. But this whole thing has to be by itself before we break it into 2 cases. So isolate it. So that's going to cancel the 3, 8a plus 10. And that's the absolute value, less than, and 25 minus 3, I think it's going to be 22. Okay. Now it's isolated. The absolute value is completely by itself on that side. Now we can get ready for 2 cases. So first case, keep it, meaning everything stays the same. The inequality is facing in the same direction and the sign is the same. So it's positive 22 stays positive 22. And again, for this one, for the second case, everything on the outside switches. So switch this and switch this. Now we can go ahead and solve both inequalities. So make sure we're doing the same thing. Well, as far as I know, most of these are you're gonna be able to do the same thing on both of them, which kind of makes it easy because you can only, you can solve both of them at the same time, so you're not doing 2 entirely different things at once. Okay, now I got to get that 8 out of there. So 8a, so same thing, 8 times a, do the opposite or do the inverse. Divide both sides by 8. And I remember, just because you're dividing by negative, that doesn't mean you flip the sign. So don't flip the sign. We can do 32 divided by 8 because that would be 4, and don't forget the negative. Now for this one here, it looks like we're going to have to get the actual number, because I mean, graphing this, you can graph it, you know, you can reduce it, divide both top and bottom by 4, you would get something like 3/2, which actually that would work out. You could just take 3 and divide it by 2, like $3, right? If you had $3 and you had to divide it 2 ways, it'd be about $1.50 or $1.50 on both of them. But if you're stuck and you're not really sure what to do, just divide it, okay? So 8 goes into 12 one time. 12 minus 8 is 4, so I get 1 4/8. And then reduce this fraction, which you're going to have to reduce it anyway. So actually, if you were able to understand what I was just describing, that would be the shortcut for working with these mixed numbers. All right, now let's go ahead and graph it. So 1.5. So let's mark out 1.5. 1.5. So that's going to be about right there. Now we want numbers less than that. So A is less than that. So just starting it off in the direction, we want numbers less than that. So that's going to be this way. And now we want A values also to be greater than -4. So mark out -4, and we want greater numbers than that. So that's going to mean that they're pointing towards each other. And if they're pointing towards each other, that's going to be an AND statement. So I'm going to put an AND symbol there because, again, I just don't know why every time I do this, every time I have an AND, I always like write them closer to each other or something. Like I could fit an OR in there, or maybe it's just AND is just a little bit of a longer word than OR. So I don't know. I don't think it should make a big difference though. Anyway, so let's go ahead and put it into interval notation. So starting with our lowest value, which is 4, but not including 4, all the way to 1.5, but not including 1.5. Okay, and that looks like we're done with this one actually. So not too bad, but we got to remember to isolate that absolute value part before we start breaking it into 2 cases and solving it. Okay. That's it for this one. Let's go ahead and move on to the next one. Okay, so this one is also not isolated. There's a -10 on the outside. And again, this should kind of warn you because there's a -10 on the outside. So this means that we're going to have to do something. And again, be careful. Anytime you see a negative, like when you have to work with the negative, in this case, definitely we have to divide both sides by -10. That should be a sign that you will flip the inequality. So I'm going to try to get into this habit of doing this first. Okay, so as soon as we know something different is going to happen, let's work with it. Okay, so just like when you recognize an emergency, you should be able to tell, okay, something's going on, I better, you know, deal with that first. All right, so the -10 is gone, so I get 2r minus 1. And then here I'm going to have, well, negative divided by negative would be positive, so that'd be +6. Oh, and we didn't do anything to get rid of this just yet. So the absolute value is still there. The only way we can get rid of it is when we break it into 2 cases. So let's go ahead and do that right now. So I'm going to break this into case 1, where everything stays the same, and then case 2, where we switch the outside parts, the outside elements. So switch the inequality so it's facing that, and then switch the sign on any outside numbers, which in this case I only have 1 outside number. In fact, I don't know if there'd be any occasions where there'd be outside numbers, where there'd be more than 1 of them. Well, I can think of them because we did have some of them. Remember, they have like a variable also on the outside too. But I don't think there's any of those with this one here. So, but again, that's always something you got to watch out for. Anyway, let's go ahead and start getting rid of all these numbers around the R. 2R, and this would be 7. 2r, and then this would be, we don't switch the sign, and this would be negative 5. All right, now I'm gonna go ahead and get the, again, we still gotta get this r by itself, so I'm gonna have to do the inverse and divide both sides by 2. So this would be r, and then 7 divided by 2. This one should be a pretty easy one. Because if I told you, think about $7, right? And you want to split the $7 two ways, what would what would it be? You could probably easily get it. But if you're not sure, you can always just divide it. 7 divided by 2. So 2 goes into 7 3 times. 2 times 3 is 6. These two numbers here. 7 minus 1, I'm sorry, 7 minus 6 is 1. I already kind of know what's going to happen, so I'm just, it's like trying to tell a joke and you're trying to get to the punchline. So sometimes you tell the punchline early. And there we go with this one. So we're done with that. So r is greater than 3.5. R is greater than 3.5. So we're going to go this way. And now we're going to go ahead and do this side. So r is less than, and we can do the same thing here. We would have to know that it's negative because when we do this, usually we don't consider the negative. So if you know something is negative and you're going to do long division, write that out first. So in this case, I have 5, but again, we ignore the negative for now. And it goes in there 2.5 times. And again, we can just use our long division for this, but if I told you to take $5 and split it two ways, you'd probably know that would be $2.50 or $2.50. All right, so now we have negative 2.5, so that's going to be over here. Yeah, some students might mistake it for here because they're used to half being on the other side when it's a positive, but it looks like we'd have something over here. Now they're facing in opposite directions, which would mean that this is an or statement. Because again, I cannot pick both of them. I have to choose one to go. So the first solution area is from negative infinity to negative 2.5, including the negative 2.5. So square bracket, because in this case we are including 3.5. And this one goes from there all the way to infinity. So there we go. That is the solution areas for that one. Okay, it looks like we're ready to go on to the next one. All right, so again, we got to isolate that absolute value. So those bars, we got to get those things by themselves. In this case, we have two things going on. It's being multiplied by 9, and then it's having 5 subtracted from it. So to get that by itself, now again, just pretend that this is all one big variable. Like if I had 9k minus 5, and this is just a simpler way to think about it because, I know some students will look at this and be like, oh, 3 minus k, that's confusing. And I can understand. So just kind of in your mind, imagine that this is all one big variable. So 9k minus 5 or something like that. So now we can see what we're supposed to do. We're supposed to, well, add 5 to both sides and then divide by 9. So it's kind of like solving an equation inside of an equation. All right, so I'm going to add 5 to both sides. But again, we're not getting rid of this this part here. Okay, this is just a way of thinking about it. so that you know what step to do next. And I'm pretty sure that'd be 72, and that would make sense because I can easily divide that by 9. So divide both sides by 9, and that should cancel this out. So now I no longer have a times by 9, but just to write it again, I'm going to write it again so that way I know that we are going to have the absolute value inequality, the absolute value part isolated on the inequality on this side. And that makes sense so far. I don't think we missed anything. So now that it's isolated, we can break it into 2 parts. So first case, keep it. So nothing changes except for getting rid of the absolute values. But again, there's also that other case. What if we put a negative number in there? That will also work. So that's why we have to flip this. And the reason we flip the mouth is pretty much for the same reason of multiplying or dividing everything by -1, right? Because if there's a negative in there, that would mean like pretty much everything gets flipped. The -1 is gonna flip everything. So that's why that gets changed. Let's go ahead and solve both of these. So I'm going to -3 from both sides. And also on this one too, because again, it's practically the same thing. Now this is where you should be like, okay, well, something's going to happen because I have a negative on the variable. And that's an easy way to spot it. It doesn't always happen that way because, you know, we've had one example, I think a few of them ago, where the negative was not on the k, but we ended up having to reverse the sign anyway. But that's usually one of the easiest things to spot. That's going to tell you, okay, be careful because you are going to have to flip that sign, because in this case we're not solved yet. All right, we got to get rid of this negative off of the k. And that means, and in this case, I'm gonna do the 2 different things. Okay, when you're working on these, you can just pick one of them, but there are 2 things you can do. This is usually, and again, this is what I was taught when I was in school, so this is usually kind of what I think of. But you can also divide both sides by -1. And when you divide both sides by -1, you know, like for this one here, we're multiplying everything by -1. Over here, I'm going to divide everything by -1. So now you can see that all 3 of these need to switch. And over here, you can see that all 3 of these things inside here need to switch. And this is kind of mentioning that, like when you're isolating, like in that last example, which one was the last one? Like number 5. When we worked on number 5, we switched. We had to divide by the bottom number to get rid of the fraction. It's pretty much the same thing. This is making it all one big fraction. So this is distributive property, but distributive property can also work with division. Okay, that part's not really too important, but it's just something to watch out for. Okay, so switch this from negative to positive, switch this direction, and switch this from positive to negative. So that's got to change also. So both things, well, actually everything changed. All 3 of them change. Same thing with this one. Change, change, change. Now we're ready to graph it. So mark out k values less than -5. Now be careful because these number lines here are going by 2s. So 2, 4, 6, 8. So pay attention to that, because I don't think it's going to happen, but I'm guessing that maybe some student's going to be like, oh no, where's 5 at? All right, so k values less than 5. And again, plug a number in if you're not sure and see if it works out. If you plug in something like this, k0 is less than -5. No, it's not true. So it should face away from anything that's false and towards anything that's true. And k is also greater than 11. So I'm going to go ahead and mark out 11. And we have k values greater than that. And plug in something like 16. 16 is greater than 11. That's true. So we know both of these are facing in the same direction. And again, they're not going to face the same direction. They're never going to both point, you know, right or left or anything like that. They're never going to do that. And one, just to describe it too, I thought of a better example. Let's say that you need, like if you're gonna, let's say that there's two laws. Okay, so like one, I can't think of any state, and I don't think there is any. But let's say a state says you need to be 17 in order to get a driver's license. All right, but federally you have to be 16 or older or was it 18 or older to get the driver's license. No, it was something like, okay, you can start working on it at 16. Okay, so if you have to be 16 or 17, why do you even need the 17? Because if you're older than 16, you already fulfill both conditions, right? So it doesn't make sense to have two rules for two different things. So that's why that's just a really quick example of times that you would not have them face in the same direction. Because if it's an and statement, you only need one of them. You'd have to go with the more strict rule. Like if you're trying to go on a carnival ride and it says, the carnival ride says you must be at least 4 feet tall. Well, what if there was another rule? You have to be 3 feet tall and 4 feet tall. Well, if you're already 4 feet, then that means you fulfill both conditions. If you're 3.5 feet tall, like 3 foot 6 inches, then you only satisfy one of them and you miss. Remember, with an and statement, you need both of them, so that doesn't count. So why would you have that first rule if you had to fulfill the second rule? So again, that doesn't make sense either. So that's why they don't usually face in the same direction. And those are just some really quick examples that I could think of. All right, time is pretty good actually. Let's go ahead and move on to the next one. Now we have stuff going on here. There is some stuff going on with the absolute value. So we got to we got to isolate this first. So we got to get this out of here. We got to get this 7 out of here and get that 6 out of here. So both of those things have to go. And again, just if you were working on any ordinary algebra problem, you do your addition and subtraction first. So that means we're going to minus 7 from both sides. And that would be 30. And then divide both sides by 6, because I got to get that 6 out of here, right? We don't want any numbers outside of that absolute value thing to be there. There you go. Now this should be isolated. And 30 divided by 6 is 5. So now that it's isolated, we can go ahead and start working on both cases. So to get both cases, keep it and switch. So switch both things there. Whew. Now again, the n has a negative attached to it. So this is the easiest thing to look for. Now that's not the only thing, but it's the easiest way to find out whether or not you're going to have to switch this, which in this case, I have to get rid of that negative. And since that negative is multiplying to n, that means I'm going to have to divide by a negative. So watch out for that. And again, this is like the easiest thing that people miss. They don't flip the sign and then they keep going. But again, we got to flip the sign. All right. From here, we can go ahead and what do you call it? Graph it. Sorry, getting a little bit spacey here. Okay, open circle because it's not included. And we want n values less than 1. And for this one here, we want n values greater than positive 1. So we have 2 that are facing in opposite directions, which means this is going to be an or statement. So to write the answer, I have to say that n is either less than -1 or n can be greater than 1. So either of these, anything under here, you know, it's going to make us happy. It's going to make it true. So if I pick 5, it'll make this one true, not that one, but that's okay because we only need one of them to be true for an or statement. Now for interval notation, starting from the lowest number, we have negative infinity, going to -1, which is not included, so round parenthesis. Over here we have 1 on to positive infinity. Another one down. All right, now pay attention to this one here because I had 2 things that we had to do with this one here. Because this next one here, I get a lot of students that miss this one, which is kind of a mystery for me, I guess. I don't know. Maybe I can kind of see why, because looking at this, usually most students would do something like -5, you know, something like this. Okay, now this is wrong. This is not the next step. But they want to put these together. But remember, these are 2 different operations. The 4 is being multiplied to x, and the 1 is being subtracted from x. Now, looking at this one, you could easily make it look like that, and that's why I kind of pointed it out on the last slide, because if I could make it look like this, and it would be the same thing. Switch the order of the 1, in this case the -1, move it to the end, and it would still mean the same thing, and it would be less confusing. So this is commutative property at work here. So again, don't fall into that trap of adding these 2 things because they're not the same thing. One is multiplication, the other is a subtraction. All right, now let's actually get to working on it. So now we're going to be working on the problem because again, what I just said, this is being subtracted, so don't confuse them. And this would be 20. And now I have to get rid of this -4. Now again, this -4 is not on the x, so it's a little bit tougher to spot, but it is still something that we are going to have to watch for anyway, because in this case, to get rid of that negative, I am going to have to divide both sides by a negative. And again, that's the thing that you really got to watch out for. So far, we've already used this a number of times, and not just in this lesson, but in lots of lessons. So be careful because it is one of those things that you do have to watch out for. Oh, and flip that sign. Remember, I said that you should flip that one first, get into the habit of doing that. Here, I'm not even getting into the habit of it. All right, so positive divided by a negative is going to flip the sign. And again, you're going to notice that when we switch, so switch, switch, it's the same thing. Switch, switch, so keep it, switch, switch. We didn't break it into 2 cases yet, but that's actually what's happening here. So that's why when we use the keep it, switch, switch, one stays the same and the other does not have the inside change, but the 2 outside things change. So in this case, you got to see it right here in a way. So maybe if you're thinking about it, you'll see why the keep it, switch, switch works. Because in this case, we did divide both sides by a negative, and it did almost keep switch, switch. Because again, the mouth switched here, the sign on the outside number switched. So when we do that, we have to also do it to this as well. Anyway, let's go ahead and get this x by itself. So now we got to solve both of these. So x is, let's see, -14. And again, when you add or subtract, that's not going to cause the mouth to change the direction of its opening. Only when you multiply or divide by a negative. So in this case, 5, minus 9 is going to be a negative number, but that's not going to cause it to switch. All right, so let's see what we got here. X is greater than -14. All right, mark it just a little bit. Oops. Closed circle. And we're looking for x values greater than negative 14. Now be careful, because like some of these are pretty skewed. So like negative 18 to negative 2, so there's actually no positive numbers on this graph. And there's also another thing too, is if you get a number that's off the graph, that's probably a hint that you got it wrong somewhere, that you're missing something. So if you ever get a number that's not on this graph, you should probably check your work. All right, now x is less than negative 4, so it's going to be going this way. So I want all numbers between negative 14 and negative 4. And the interval notation for this one's going to be pretty easy, right? We include both of them. And one thing that makes this one kind of easy is that both of them are going to be the same, right? So if there's brackets, it's going to be brackets on both of them. If it's parentheses, it's going to be parentheses on both of them. All right, so in this case, my interval is closed. They're facing towards each other, so that means that this is going to be an AND statement. So I'm going to spell out the word AND if I have enough space, which in this case I did. I was watching out for that one. So in this case, yeah, that is going to be an AND. So I spelled it out, didn't put the AND symbol there. Okay, so looks like we're done with this one. Let's go ahead and move to the other one. Wait a minute. Something's not right about this one. Oh man, you know what? There's a negative missing here, which would actually make this one positive. 5 here, and I would change this one and change this one here. The numbers would still be the same actually. And this is why I always say you gotta not be afraid to check your own work, because in this case, we almost missed something here. 5 minus 9 would be negative 4, and this would be negative 14. And actually, you know, this is not a bad thing, because you can easily see now what kind of effect switching a sign has. And in this case here, x value is greater than negative 4 and less than 14. So hardly anything changed, just the direction of the movement of both of those things. But we're also going to have to rewrite the this thing here. So, oops. But again, not a bad learning opportunity, because, you know, mistakes just happen sometimes. Nobody's perfect. There we go. Yeah, and in this case here, the only thing, you know, I probably was focused so much on switching the sign that I forgot to pay attention to the negative here. Whew, so we didn't have to change everything, just to change a few things. All right, so we gotta be cautious on this one here. So make sure we don't miss the signs on any of these here. (24 plus 9), that would be 33. All right, and then continue trying to isolate this. So 8x plus 5. And 33 divided by 3 would be 11. And now it's isolated, so we should be able to get our two cases. So keep it. And switch. So switch both of these, check it, make sure you're switching, you know, both outside elements on one of them. All right, now continue solving it. So looks like we're gonna have to get rid of this 5, so minus 5 from both sides. So 11 minus 5 is gonna be 6. And over here, let's see what we got. We have negative 16. All right. Now we got to divide both sides by 8 because we got to get this 8 out of here. So divide by 8, divide by 8. 6 divided by 8. So 6 divided by 8 is not really going to work out all that well. So in this case here, we're going to have to reduce it. So x, and I cannot divide 8 by, I can't divide 6 by 8 or 8 into 6 because, well, it's just not going to work out. So if you can't divide it, just reduce it. So here we go. We got x is greater than 3/4. And 3/4 is between 1 and 2, but kind of closer to 2. And let's see, we want x values greater than that, so it's going to be pointing this way. Now we got to do this one, and we got to find out where it's going to go, because they could be facing away from each other or towards each other. In this case, it would be x is less than -2. So mark out -2, use a closed circle, and we want x values less than that, so we got to go this way. And there we go. Whew. Okay, checking it really quick, make sure I didn't lose a negative or something somewhere on this one. Okay, this one looks good to me, so I guess we're ready to put it in interval notation and call it a day. Oops. We're going to start from here, from -infinity on to, actually in this case it would go to -2, looking at it from here. And it is included, so we are going to have to use a square bracket. And then from here we have, let's see, starting from 3/4 for the second interval, because again, remember, this means that there's this area and then there's this area. So this one starts from 3/4 on to infinity, including 3/4. So we would need a square bracket for that one. Okay, this one might time very well just because, well, we only have one more problem, and that's about as much as we have time for. So let's go ahead and get to that last one. Ooh, let's be ready for anything on this one here. So again, we have two things, two separate things we got to do before we isolate it. So to isolate this, we got to get rid of this 9. So again, just think of it like a regular equation. So we got to do the addition subtraction first. And in this case, 75 plus 9 would be 84. And then I'd have to divide both sides by 4. And that's going to cancel this 4, because any number times 4 and then divided by 4 is pretty much just going to end up right back where it was. And let's see if this is isolated. And 84 divided by 4, I'm pretty sure this is 21, because 8 divided by 4 is 2, 4 divided by 4 is 1, so 21. Now, let's go ahead and break it into two cases. So keep it and switch, switch, switch. Now in this case, I can see there's a negative on the n number. So I got to be careful, right? That's an obvious sign that something might happen that we're going to have to watch out for. So just be aware of it. Don't flip the sign just yet, okay? Because sometimes it might look like something's going to happen, but something might not happen. And in this case, it looks like we get 12, -3n, and in this case, I get 30. Oops, better be careful. Don't want to lose any more negatives. Check your signs. Check it again, make sure everything looks fine. That should be a positive, okay? And now let's go ahead and divide by -3. Oops, see, I said it right there, divide by -3. So flip the signs like I said, I'm going to try to get into that habit of flipping the signs first so that I know that something's going to happen. And here we got -4, and here we're going to have +10. Now we just got to graph it. So n has to be greater than -4, and n has to be less than 10. So again, just reading it from left to right, n less than 10, or plug something in and see if it works out. So 4 should work on both of these. 4 is greater than -4, that's true. And 4 is less than 10, that's also true. You know, plug it in, write it out, make sure it makes sense. And since it's going towards each other, that's going to be an AND statement. So those are the two solution areas written like this, graphed out. Now we got to put it in interval notation. So in this case here, -4 and 10, but it's not including either of those things. So we're going to have to use the parenthesis on those. And that's all of them, actually. So we actually managed to get through all of these. Actually, I don't think we ever, it's very rare that I actually run out of time, but looks like bell's gonna ring. So that will be it for today. That's it for today. I will see you guys next time. All right, thanks for stopping. Bye.